Ladies and gentlemen, welcome back. We've been told to find the value of x, that is in negative 5 raised to power x is equals to 12. Now to solve this problem, negative 5 raised to power x is equals to 12. We shall write it as negative 5. We shall write as negative 1 times 5. So that when you use the laws of indices to separate the two, the power outside multiplies the powers inside because of multiplication sign. So there we will have in the first bracket negative 1 raised to power x, then it is times 5 raised to power x to be equals to 12 when you use the laws of indices. Now, negative 1. What is negative 1? Negative 1 is going to be a complex number when it is raised to any number. So there we will use the Euler's equation. Remember, in Euler's equation, when you have exponential raised to power, pi I, that will be given by cos pi plus I sine pi. Remember, if pi is theta, where there is pi, if you put theta, the Euler equation is exponential theta I is equals to cos theta plus I sine theta. So if theta is pi, where there is theta, we put pi. If theta is pi, we'll have exponential pi I is equals to cos pi plus I sine pi. Then, remember, so if you simplify this, cos pi is like cos 180 degrees, that will be negative 1. Then sine pi is 0. So you have 1 plus 0, I. Then you remain with the answer there to be negative 1, because I times 0 is 0. So it means where we have negative 1, we are going to put exponential. We've now found that exponential pi I is the same as negative 1. So back to our equation here. The equation we had negative 1 raised to power x times 5 raised to power x is equals to 12. So negative 1 we found is the same as exponential pi I. So where we have negative 1, we are going to substitute with this value, which is exponential pi I. So when you take x, the power outside multiplies the power inside. When you bring x inside, if you multiply it inside the bracket, we'll have exponential x pi I. Then 5 raised to power x, if you introduce exponential and ln, this will be exponential. Ln is the inverse of exponential function, so that will be exponential ln of 5 raised to power x. So exponential ln of 5 raised to power x is equals to 12. Now here, when you use the laws of indices, will have same base with multiplication sign. We'll have exponential raised to power x pi I, then it is plus ln, of 5 raised to power x. Remember, ln of 5 raised to power x is the same as what? It's the same as x ln of 5 according to logarithms. X ln of 5 to be equals to 12. Now, for us to get x, remember x is a common factor here. So if we factorize out a common factor, when we factorize out x inside bracket, we will have pi I plus ln of 5. Now from there, for you to get x, we introduce natural log on both sides. So if you introduce natural log ln on both sides of the equation, ln on both sides, the power will become the coefficient. That one will become the coefficient according to the laws of logarithms. Then ln of exponential raised to power 1, that is ln of e. Ln of e is 1, so that one disappears. You remain like that. So for you to get x, it means we will divide. When we want to get x to remain with x, we will divide both sides of the equation with the coefficient of x. So if you divide both sides of the equation by that, this side of the equation again, you divide by that. Then you end up with pi I plus ln of 5 divided by pi I plus ln of 5 will disappear. Then we will remain here with x. So we'll remain with x. These terms are the same, will disappear. So we'll remain with x is ln of 12 over pi I plus ln of 5. And that is how to solve such kind of problem. Thank you for watching and tune in for our next video.